We are not doing as much today as I planned to do, so you won't have any homework tonight. I know y'all are sad.
Great.
What you whining about? Oh, I'm not gonna change my plans just because she's whining. We're good.
I wasn't wanting them.
I know you weren't.
She doesn't show me attention.
That's all right. Okay. So we're supposed to get all the way through 6.2, so I'll back it up on Canvas, but we're not going to make it all the way through because I just don't want another whole day of notes like we did yesterday. If you have any work from this week that you haven't done, you need to get that done. Zoomers, if you have any work that you haven't turned in this week, you need to get it done. Otherwise, it's going to be zeros by the time we walk in on Monday. You should do your work every day. That 5 days that you're supposed to have for leeway is not if you sign in today and watch the Zoom. It's if you're out, just like normal, if you're out. So you need to start getting that work in. I'm tired of grading it 4 and 5 times. So get it turned in. All right. So combining random variables so far. Oh, why you yell at me? Can't you be, where's my little thing at? There it is. I mean, you ain't gotta yell. You ain't gotta be super loud. No, you're fine. I didn't turn on the screen for them. Sorry, guys. Most people can talk and see and hear at the same time.
Yeah, but you said, never mind, just leave. God, turn around. Turn around.
All right. Okay. All right. So far, we've looked at a setting that involves single random variable. Many interesting statistic problems require us to combine 2 or more random variables. So earlier, we examined the probability distribution for the random variable X, the number of passengers on a randomly selected half-day trip with Pete's Jeep Tours. So we've already seen this. We found out that the mean was 3.75 and the standard deviation was 1.0897. And that was for Pete. That's what we've been doing the last couple of days. And then now he's got a sister who lives near a tourist area in another part of the country, completely different part of the country, is impressed by the success of his business. She decides to join the business, running tours on the same day as Pete in her slightly smaller vehicle under the name Erin's Adventures. After a year of steady bookings, Erin discovers that the number of passengers Y on her half-day tours has the following probability distribution. So here's your probability distribution. How do we find the mean? How do we find it by hand?
2 times 0.3.
And then
You add 3 times 0.4.
next one multiplied, add it to the next 2 multiplied, add them to the next 2 multiplied. If we do it in our calculator,
That's like the one thing I know how to do.
Mackenzie, you're better than that. What do we do in our calculator? Yeah, put it in L1, L2, make sure that your frequency is what? L2. Okay, so when you reset your calculators or whatever, you need to do that. If you only have something in L1, make sure you delete that L2 out. So from chapter 2, we only had the L1, so you didn't have any frequency. But now when we have the L2, you have to put the L2 in. It will screw you up if you don't. It'll keep making an error or something like that if nothing's in there. All right. So the mean of this one, so that you don't have to work it out, is 310. And the standard deviation is 0.943. Everybody good? Yep. All right, so here's her distribution. It says, how many total passengers T will Pete and Erin have on their tours on a randomly selected day? So we want to put them together to see how much basically the family business makes. So the way we would do that is we're going to add their stuff together. So the total equals Pete plus Erin. So then it says how many more or fewer passengers. And this is the only one. This is the only one that we're working on today. Okay. That's all we're focused on. On Monday, we'll go through the different stuff. Okay. Got it? Okay. All right. How many more or fewer passengers D will Pete have than Erin on a randomly selected day? So how would I figure out how many more or how many fewer? What operation? Yeah. So I add to find the total. I do the difference, so that's why we put D, to figure out what the difference in theirs are. So who has more, who has most, whatever. As the example suggests, we want to investigate what happens when we add or subtract random variables. So we're just going to, again, work on add today. We're not getting into subtract. It's pretty much the same until you come to your variance and standard deviation, okay? So that's the only way the two of them differ. Plus is the easy one. How many total passengers T can Pete and Aaron expect to have on their tours on a randomly selected day? Because Pete averages, so his average, just to remind you again, was 3.75. And Aaron averages 3.10. They will have a total, so mu total is 3.75 plus 3.10, which gives you 3.85 passengers per day. I mean, sorry, 6.85 passengers per day. We can generalize this result for any two random variables as follows. If we're doing the total of x plus y, then all we have to do to find the mean of the total is add the two means. So in other words, the expected value, which is also called the mean, of the sum of two random variables is equal to the sum of their expected values, or means. Okay. Is everybody good? Mean of the sum of random variables, same thing that we just did. Remember, we can either do the mean or we can do something like this. The expected value of T is how you read that, which is the same thing as the mean of T is the mean of X plus the mean of Y. So it's a lot of repetition. So this chapter is a lot of repetition. So we worked on the mean, and now we're going to talk about all the variation stuff. So how much variability is there in the total number of passengers who go on Pete and Aaron's tours on a randomly chosen day? Let's think about the possible values of T equal to X plus Y. So that's adding them together. The number of passengers X on Pete's tour is between 2 and 6. And the number of passengers Y on Aaron's tour is between 2 and 5. So the total number of passengers T is between what two values? What's the littlest amount they can have combined? 4. How'd you get that? 2 plus 2. What's the highest amount they can have combined? 11. You got that from 5 plus 6. So thus the range of T, how do we find the range? So our highest was 11 minus 4 is 7. How is this value related to the ranges of X and Y? What is the range of X? Pete's range. What? 4. The range of Y is 3. So the range of the total is the same thing as the range of X plus the range of Y. So the range of X was 4, the range of Y was 3. 3 plus 4 is 7, and we found that out by doing the total as well. That is, there's more about variability in the values of T than in the values of X or Y alone. This makes sense because the variation in X and the variation in Y both contribute to the variation in T. So what about the standard deviation of T? If we had the probability distribution of the random variable T, then who's trying to get in? it chat? Yep. Ah. She has an appointment. All right, then we could calculate the standard deviation of t. Thank you for telling me. Let's try to construct this probability distribution starting with the smallest value, which is t equals 4. So how did we get that total t equals 4? What did we do? Our total passengers was 4. How did we get the total passengers to be 4? 2 plus 2, yeah. These are not hard questions and they're really simple. So don't overthink it, okay? Everything is easy. Don't overthink it. So the only way to get a total of 4 passengers is if Pete has X equals 2 passengers and Aaron has Y equals 2 passengers. We know that the probability that X equals 2 from the chart earlier was 0.15. So that's, I'll show you this chart. So for X, 2 was 15. For her chart at the bottom, 2 was 0.3. Okay, so that's where those numbers are coming from. They're not secret. So the probability, sorry, that should be a Y, that Y is equal to 2 is 0.3. So if the two events, X equals 2 and Y equals 2 are independent, then we can multiply these probabilities. In fact, we can't calculate the probability for any value t unless X and Y are independent random variables. So what are independent random variables? If knowing whether any, should say event, sorry, involving X alone has occurred tells us nothing about the occurrence of any event involving Y, should say alone, and vice versa, then X and Y are independent random variables. So like when we pull that card out, but we put it back in, did that hurt anything? When we pull a card out of the deck and we put it back in, it doesn't hurt anything. So that's independent. But if we pull it out and take it out, does that change it? Yes. So that's what it's talking about. So if we're talking about Aaron and Pete, remember Pete is in one part of the country and Aaron's in the other. Will his Jeep tour or the passenger number on his Jeep tour be affected by Aaron's? Not at all. They're completely separate. So they're both independent. So that's why we can continue with that. So think about that as you go through your problems, okay? So probability models often assume independence. When random variables describe outcomes that appear unrelated to each other. You should always ask whether the assumption of independence seems reasonable. For instance, it's reasonable to treat the random variables X equal the number of Pete's passengers and Y equals the number of Aaron's passengers. On a randomly chosen day as independent. Because the siblings operate their trips in different parts of the country. Now we can calculate the probability distribution of the total number of passengers that day. You good? You good? Okay. I just don't want to flip it over and still writing. Don't be so sassy. All right. So Pete's Jeep Tours and Aaron's Adventures, sum of two random variables. We've already kind of done this, but now we're going to put those probabilities towards it. So let T equals X plus Y. Because X and Y are independent random variables, we're gonna find the probability. So we're filling in this chart down here. We're gonna find these probabilities. So their total probability. So right now we have the two charts that are separate. We're gonna combine them together. Got it? All right, so this is how we do it. What's the smallest number they can get and how did we get it? 4, because we added their 2 and 2, right? All right. So the probability that we get a total of 4 passengers from Pete and Aaron is the probability that X equals 2 and Y equals 2. Since they are independent, we can do the probability of X equals 2 times the probability that Y equals 2. That's like the copier one on your test. That's why you multiplied it. And then from our charts, our previous charts, the probability that X equals 2 is 0.15 and Y equals 2 is 0.30, which gives you a total probability of 0.045. And that's going right underneath the 4. So now what happens if we do 5? So we got to go from 4 to 11. So we're going to go 4 and then we'll do 5. How can we get 5? How can we get a total of 5 passengers? Yep, so X is 2, Y is 3, or X is 3 and Y is 2, right? So here's what we have. The 2 ways that we can get it is if X is 2 and Y is 3, or X is 3 and Y is 2. You're going to do the same thing. The and means multiply. So you're going to do the probability that X equals 2 times the probability that Y equals 3 plus the probability that X equals 3 times the probability that Y equals 2. So from our chart, 0.15 and 0.4 on her chart, plus from his chart, 3 was 0.25 and her 2 was 0.3. Which gives you a total of 0.135.
Miss Jones, could
Yeah.
you not say like 1 and 4 and 4 and 5 because it's not on their charts or?
Correct. One, they don't have a minimum of 1. They're both of their minimums are 2.
Okay.
All right, so we can construct the probability distribution by listing all the combinations of X and Y that yield a possible value of T. So that would be 4 through 11 is what we have. So here's the results, just so you have them. The next one is 0.235. So we would do the combination of 6. Then 7 is 265. 8 is 190. 9 is 095. 10 is 030. And 11 is 005. 2 and 4 would also work. So it would be 2 and 4, 3 and 3, and 4 and 2. Yes, you would have to do all 3. And then multiply and go from there. Okay. All right, so you can check that the probabilities add to 1. That's how you know it makes a perfect probability model. A histogram of the probability distribution is shown below. Describe this for me. Symmetric. that all you got for me? The range is from 4 to 11. It is unimodal. Seems to be 7, so is 7 your mean or your median? It's a trick question. Symmetric, what do you know? If it's symmetric, what do you know? Okay, so we do use the mean, but what should the mean and the median be? Pretty close to equal. If it's perfectly symmetric, then they're going to be exactly equal. But if they're roughly symmetric, they should be around the same area. So it should be around 7 that we have our mean. So we'll check that out a little bit later, all right? Here we go. Right now. Find the mean, variance, and standard deviation of t. Interpret the mean and standard deviation in the context of the problem. So find the mean of the total. How did we do that? We already did this, y'all. Mean x, mean y, which was 3.75 plus 3.10, which is almost 7, right? Good. So it is roughly symmetric. It's not perfectly symmetric, but it is roughly symmetric. All right. So how do we find the variance? How do we find variance anyway? You do? How do we find the variance? No, you don't. That's how you find the standard deviation. What do you add? Okay. Go back and check your variance formula. I don't care. Go back and check it. 6.2. We did it yesterday. We did. I'm looking to make sure I didn't do something wrong. What is that? Say it again. Observation minus the mean. And then what do you do? Oh, but we're doing variance, right? Okay. What do you mean you don't know? You don't know anything. What's that mean? You know what it is. Looking one thing. Okay. Let me try to find one. What's your observation for the first one in your chart? 4, yeah. Minus, what's your mean? What do you do to that? Square it, and then times the probability. Then what do you do? Same thing with every single one. So it would be 5 minus 6.85 squared times 0.135. So on and so forth. I'll go ahead and tell you that it's 2.0775. And then now, how do you find the standard deviation? Thank you. Which gives you 1.441. Good. All right, as the preceding example illustrates, when we add 2 independent random variables, their variances add. Standard deviations do not add. For Pete's and Aaron's passenger totals. So here's what it's saying. You have to do the variance instead of doing the standard deviation. So you'll always have to use the variance and then find the standard deviation. Because if we actually use the standard deviation of the 2 of theirs, it was 1.0897, and then hers was 0.943, which gives us a total of 2.0327, which is very different from what we just got for the total of 1.441. So for any two independent random variables, X and Y, if the total is X plus Y, the variance is, so the variance of the total is the variance of X plus the variance of Y. And then remember to find the standard deviation, you take the square root from there. So in general, the variance of the sum of several independent random variables is the sum of their variances. All right, so pay attention to this one. College uses SAT scores as one criterion for admission. Experience has shown that the distribution of SAT scores among its entire population of applicants is such that for math, the mean is 519 and the standard deviation is 115. For reading, the mean is 507. The standard deviation is 111. What are the mean and standard deviation of the total score of X plus Y for a randomly selected applicant to this college? How do I find the mean? How do I find the mean? Mean of X plus mean of Y, which is 519 plus 507, which gets you 1026. How do we find the standard deviation? Do not add standard deviations because it gives you the wrong answer. Okay. Okay. What was the stipulation to be able to find standard deviation? What was the one stipulation to be able to find the standard deviation? What do they have to be? What do the variables have to be? Why could we do Aaron and Pete's Jeep tours together? Because they were independent. Are these independent? Why? Say what you're gonna say. Yes, you do. What were you gonna say? Come on, you could be a really smart person right this second. Because I feel like you were gonna say exactly what I needed to hear. Not the same test. Okay, so typically, is it like a, well, typically, have you guys taken SAT yet? You took the PSAT, right? How were your scores in math and reading? Were they a lot better in one or the other? Or were they kind of like, oh, yours were flat? Okay. A lot of that could be because you haven't taken higher math, but were your English scores better than your math scores? That's why, because you haven't taken a lot of the math scores that are on the SAT. So by the time you actually take the SAT, you should have taken your higher level math. That'll even that out a little bit. So typically what it's saying is if you do good on the math score, you're pretty much going to do good. You're not going to bomb it. It's not going to be like this. So these are actually not independent. So your standard deviation, you guys taking the ACT? Some have, your score is pretty, yeah, pretty even on that. Because usually if you do good, it's still the same thing. It's okay. So the standard deviation should say calculated, sorry, can't be calculated. Because they're not independent. And again, the reasoning behind that, if you score high on one, you typically score high on the other. You're not far off when you take them. Okay, it's not like I don't even know what the scores are anymore. It's not like you're gonna get like a 500 on one and a 300 on the other. You're gonna be pretty evened out. All right. So just watch that, make sure that they're independent and one doesn't affect the other. All right, I'm gonna flip it. Earlier, we defined X equals the number of passengers that Pete has and Y is the number that Aaron has. Recall again that the mean for X was 3.75 and the standard deviation for X was 1.0897. Mean of Y was 310. Sorry, standard deviation of Y was 0.943. Pete charges 150 per passenger and Aaron charges 175 per passenger. Calculate the mean and standard deviation of the total amount that Pete and Aaron collect on a randomly chosen day. So we can do both of these because we said Pete and Aaron were completely different, right? Okay. So now what we're doing is adding a number. So we're just trying to figure out, we did this yesterday. We did it with just Pete doing the 150, right? So you're doing the same thing, except for now you're adding another set. You're adding Aaron as well. So we're going to call this W for the total amount collected. That's what the book calls it. I would probably not call it that. Yesterday we did C because it was the amount collected for Pete. So it was just that one. So they're trying to keep the variables different as they're continuing through this whole process. So how would we find the total amount collected? If he charges 150 and she charges 175. What's my formula? So yesterday, when we were looking for Pete's, it was just 150x. So what would Pete's and Aaron's be? Perfect. That's exactly what I'm looking for. So then how do you do the means? You would do the mean of W equals 150 times the mean of X plus 175 times the mean of Y. So we would do 150 times 3.75 plus 175 times 310, which gives us a total of 1105. So on that one day, they would collect $1,105 together. So then how do we find the standard deviation? We can find it because they're independent, but we cannot add the standard deviation. So what do we have to add? Okay. And then we're going to square root it to find the standard deviation. All right. So how do you get the variance? That's one.
Huh?
That's one.
It's like you keep it count.
That's the only time I look. All right. So the variance of W is going to equal what? You're working too hard. Working too hard. Yeah, we already have our standard deviations, right? We're not trying to find them like you're making it too complicated. You're making it too complicated. Yes, you do. You do square root the square the standard deviation. But what else do we have in our formula? What new part do we have to our formula? Here's our formula, the amounts of money. Thank you. So if we square to get the variance, what do you think we have to do to that amount of money? That's where I'm going with this. So you have to do 150 squared times the variance of X plus 175 squared times the variance of Y. That's the
Can
part
you
people tend to forget.
explain that? Like, I couldn't hear the people talking in the class.
I just said, what's the difference in our formulas? So before it was just X and Y, so we were just doing the variance squared plus the variance squared. Now we're adding that money value in, so you have to make sure that you square those as well. That's it. So just make sure you square them. So then we have 150 squared. Our standard deviation for X was 1.0897. We're going to square that. Plus we have 175 squared. And then 0.943 squared.
So when do we know when to square them?
When you add that money value in.
Like,
So when we did the total and we were doing it by hand, we were just doing, so the last time, I'm gonna run out of time because I'm answering this question. Not in a bad way, I'm just telling you. So when we were doing this, we were just trying to find one standard deviation. We were not trying to find the total. So we don't square it then. Does that make sense? We only square it when we're adding it to another value. This is just one value's standard deviation. This is not standard deviation times a monetary value. Does that make sense? So anytime you change that formula away from X, Y, or whatever we have from this, you have to square whatever that value
I
is.
thought we were finding the variance right now.
We will to find the standard deviation. Our goal is to find the standard deviation. You get 53950.79. Again, that's your variance, but to find the standard deviation,